Somewhere beyond the familiar geometry of the solar system, there may be a world whose night sky contains a very ordinary star with a very unusual secret. To its astronomers, our sun would be only one point among thousands. A yellow star neither especially rare nor especially dramatic, steady enough to invite curiosity and close enough to reward patience. But at precise intervals, a tiny shadow would cross its face. The light would dim by a fraction so small that no eye could notice it, yet a careful instrument would understand. A planet is passing in front of that star. A small, rocky world. A world with oceans, clouds, weather, continents, and a thin blue atmosphere that has been speaking long before any human voice reached the sky. If aliens are already watching us, the first thing they may have seen was not a city, a satellite, or a radio broadcast. They may have seen chemistry, oxygen behaving strangely, methane refusing to disappear, water vapor shifting with seasons. The spectral fingerprints of a living planet would have arrived at their instruments as a puzzle written in starlight. Long before Earth became technological, Earth was visible as a biological disturbance, a planet whose atmosphere did not rest in easy equilibrium. Life had altered the air, and the air had become a message. The unsettling possibility is simple. We have spent decades asking whether anyone is out there, while forgetting that Earth has been visible from outside for billions of years. We imagine contact as a future event, a signal arriving, a ship descending, a word crossing the dark. But observation requires no announcement. A civilization only slightly older than ours, positioned in the right part of the sky, with instruments somewhat better than our own, could know that Earth exists, could know that it is alive, and could have noticed that something changed here recently. That possibility changes the emotional shape of the question. The oldest human stories looked upward and filled the heavens with intention. But modern astronomy removed that comfort and replaced it with scale. The stars became distant suns, the planets became physical bodies, and Earth became one world among many. Yet the new astronomy also gave the old unease a scientific form. A planet can be found by its shadow. A biosphere can be suspected through its air. A civilization can reveal itself by altering the surface that carries it. We may not be watched by gods, but we may be visible to instruments. The most powerful way to find a planet is often to wait for it to betray its star. When a planet crosses in front of its sun from our point of view, the star dims by a minute amount. This method, called the transit method, has revealed thousands of worlds because it turns darkness into evidence. The planet itself may be too faint to see, but its silhouette is enough. A slight decrease in light repeated with clock-like regularity can reveal a world's size, orbit, and sometimes even its atmosphere. We have used this method to discover planets that circle other stars. From somewhere else, the same method could be used against us. Earth is not hidden from the universe in any absolute sense. It is hidden from most angles because the geometry must be exact. An alien astronomer must be located near the plane of Earth's orbit to see our planet pass across the sun. That narrow region is called the Earth Transit Zone. From there, Earth becomes a detectable exoplanet. The sun dims by a tiny fraction every year, and that yearly dimming carries the signature of a small rocky planet moving through the habitable zone. With enough patience, the observer could measure our orbit and infer that Earth receives the right amount of sunlight for liquid water. A more advanced instrument could go further. During a transit, some sunlight filters through the edge of Earth's atmosphere before continuing into space. The gases absorb specific wavelengths, leaving dark lines in the star's spectrum. This is how a planet's air becomes readable from a distance. Oxygen, ozone, carbon dioxide, methane, nitrogen, water vapor, and pollutants all leave traces. From across interstellar space, Earth could appear as a living world, not because anyone sees forests or oceans directly, but because the planet's atmosphere carries the chemical unease of biology. This is how watching begins. It does not require a telescope large enough to photograph our continents. It does not require alien myth, invasion, or intention. It requires geometry, patience, and a culture that has learned to read shadows. To a distant observer, Earth would first be a periodic defect in sunlight. Then it would become a world with air, then a world with water, then a world where the atmosphere has been remade by living organisms. The discovery could unfold quietly across generations, as one measurement becomes a catalog entry, and a catalog entry becomes a question that refuses to leave. There is a strange humility in this method. It does not begin with the richness of a world, only with the loss of a little light. A planet hides inside a star's brief dimming, and from that modest event an entire reality is inferred. Human astronomy has already learned to perform this act of reconstruction. We can take a slight periodic shadow and derive a body's size. We can take a spectrum and infer air. We can take motion and infer mass. Any older civilization would likely have gone further, refining the same logic until a distant planet could be treated almost like a place in a map. The first alien observer to notice Earth might not have felt revelation. It may have been a routine detection in a survey of many stars, a small planet, a stable orbit, a yellow star. The importance would emerge slowly as the measurements accumulated. The orbit lies in a temperate range. The atmosphere contains unusual chemistry. The planet has water. The same target deserves another season of observation, then another decade, then perhaps a permanent place in a catalog of living candidates. For most of its history, Earth was a planet without witnesses, unless the witnesses were far away and patient enough to understand what they were seeing. The first signs of life would not have looked like civilization. They would have looked like disequilibrium. On a lifeless world, reactive gases tend to settle into stable arrangements. On a living world, chemistry is constantly disturbed. Organisms consume, release, transform, and recycle. They pull carbon from air and stone, release oxygen into sky and ocean, and fill the atmosphere with signals that should not persist unless something below is renewing them. The great transformation came when photosynthetic life began changing the planet's air. Oxygen accumulated slowly, then dramatically, turning Earth into something rare and conspicuous. To a distant telescope, oxygen alone might be ambiguous, but oxygen combined with methane and liquid water would raise difficult questions. Methane should be destroyed by sunlight in an oxygen-rich atmosphere, so its presence requires replenishment. Life can do that. Geology can sometimes imitate pieces of the pattern, but the whole composition tells a more complicated story. Earth's atmosphere became a kind of planetary confession, written without intention and broadcast in reflected light. An alien civilization watching over geological time would have seen the planet pass through stages. There would have been the young world with a restless surface, then the long microbial age, then the oxygenation of the air, then the greening of continents, then the slow rise of complex ecosystems. They might not have seen animals directly, but they could have watched the atmosphere mature. They could have seen seasonal pulses, vegetation altering reflected light, oceans stabilizing climate, ice advancing and retreating. Earth would not have appeared as a finished world. It would have appeared as a world becoming more interesting. Then, very recently, a new signal would have emerged. Industrial civilization began altering the atmosphere with unusual speed. Carbon dioxide rose, methane increased, artificial compounds appeared, some with no easy natural explanation. Night-side light, radio leakage, radar, satellites, thermal patterns, and orbital debris would all belong to a different class of evidence. A planet that had already been biologically strange became technologically suspicious. From far enough away, nothing about us would look human. It would look like a planetary system entering a new phase of activity. That speed would matter. Geological change is usually patient. Continents drift, mountains rise, ice sheets advance, oceans absorb and release heat across vast durations. Human industry changes the air on a scale that would look abrupt even from a distant scientific culture. A watcher who had archived Earth for centuries might see a curve bend upward with unusual violence. The planet's atmosphere would begin to carry the signature of extraction, combustion, manufacture, and agriculture intensified beyond anything the previous record suggested. The strangeness of Earth, then, is double. It is a living world which may already be rare. It is also a living world in the early fever of technology, which may be rarer still. A distant civilization may distinguish between a stable biosphere and a biosphere that has produced a species capable of altering the whole planet. That second category would demand a different kind of attention. Life is a phenomenon. Technology is a direction. The idea that aliens could watch Earth is not spread evenly across the sky. Space has directions that matter. Most stars cannot see Earth transit the Sun because they are not aligned with our orbital plane, but a thin band across the sky offers a privileged view. From there, our planet crosses the face of the Sun once per year, and its shadow reveals the existence of a small world in a temperate orbit. This turns the usual search for alien life around. Instead of asking where we can find planets, it asks where planets can find us. There are thousands of stars within a few hundred light years that either have had, now have, or will have the right geometry to observe Earth as a transiting planet. Stars move. The galaxy is not a fixed map. Over thousands of years, stellar positions change, and different systems enter or leave the viewing zone. A civilization that missed Earth's transit 10,000 years ago may see it in the future. Another that sees us now may lose the alignment after many centuries. Observation is not simply a matter of distance. It is a matter of time, motion, and perspective. Some of those stars may host planets, some may host rocky worlds. A smaller number may host conditions stable enough for life. A far smaller number may have produced observers. The chain narrows quickly, but the galaxy is vast enough that even narrow possibilities deserve attention. We already know that planets are common. The age when Earth could be imagined as an isolated miracle is fading. Our instruments have found worlds around red dwarfs, sun-like stars, compact multi-planet systems, hot giants, frozen planets, lava worlds, and planets with densities and orbits that once seemed improbable. If a civilization exists in the Earth transit zone, its first advantage would be simple. It would know exactly where to look. Earth would announce itself through a recurring dimming of sunlight, and the atmosphere would provide clues worth revisiting. Once a world appears promising, observation becomes cumulative. Telescopes improve, archives deepen. The same target is measured across decades. A patient civilization could build a history of Earth without ever crossing the distance between us. We might be a file in an observatory older than our oldest cities. The movement of stars adds another layer of melancholy. A world that can see Earth today may not always have been able to see it, and a world that cannot see us now may gain that view in the future. The galaxy is often pictured as a still image, but it is closer to a slow river of suns. Every star carries its planets through changing angles of visibility. From one century to another, the sky rearranges the possibilities of discovery. Earth may enter and leave other civilizations' sightlines like a lantern passing behind branches. For an older species, this motion would be part of the search strategy. They would not merely ask which stars are close. They would ask which stars have the right geometry, which will soon enter the right geometry, and which carried that alignment during the rise of Earth's technological phase. Their maps would be four-dimensional. Their astronomy would include not only where stars are, but where they were, where they are going, and which planets they might have revealed along the way. The most difficult idea to accept is that direct travel is unnecessary. Human imagination often turns alien observation into ships, probes, ruins, or hidden machines. But an advanced civilization may learn more with light than with engines. Light travels freely. It carries information from every surface it touches, every atmosphere it crosses, every star it leaves behind. A telescope does not need to arrive at Earth to know Earth is there. It only needs enough collecting area, enough time, and enough intelligence behind the instrument. From Earth's transit, alien astronomers could estimate our planet's radius. From the Sun's properties and our orbit, they could infer the energy we receive. From repeated observations, they could calculate the length of our year. From slight gravitational effects, they might infer other planets in the solar system. A full architecture could emerge. A yellow star, rocky inner planets, giant outer planets, belts of debris, icy bodies, and a small temperate world with an atmosphere worthy of suspicion. The solar system would become a structured place in their models, not a vague point in the dark. Spectroscopy would reveal the atmosphere as a layered message. Oxygen would indicate powerful chemistry. Ozone would suggest ultraviolet interactions. Carbon dioxide would help describe climate. Water vapor would point toward oceans or humidity. Methane would complicate the picture. Seasonal changes might reveal biological cycles. A faint vegetation edge in reflected light could suggest photosynthetic surfaces, though such a signal would be difficult to measure across interstellar distances. With better instruments, the alien observers might track cloud cover, rotation, and perhaps even the contrast between oceans and continents. Technological signals are harder, but not impossible in principle. Human radio leakage is weak and often fades into background noise at interstellar distances, but certain transmissions, radar beams, and powerful directed signals could travel farther. Atmospheric pollution might be more revealing than radio. Industrial gases, artificial compounds, unusual thermal waste, and night-side illumination would tell a broader story. A civilization may not hear our conversations, but it could notice that Earth's atmosphere changed faster than geology usually allows. It could see that a living planet had started to engineer itself, clumsily and unevenly, on a planetary scale. The most unsettling part is that they would not need to understand us to classify us. They would not need to know our languages, our borders, our religions, or our private griefs. The evidence would sit at a colder level. Energy, atmosphere, orbit, radiation, chemical imbalance. We study distant worlds in the same stripped-down way. We reduce them to radius, mass, temperature, density, and spectral lines, because that is all the distance allows. From across the stars, humanity may not appear as humanity. It may appear as a new category of planetary behavior. An observer with extraordinary instruments might try to separate natural variation from technological interference. Does the planet's night side brighten in fixed patterns? Do emissions follow surface geography rather than weather or geology? Are there narrow-band signals that repeat with artificial precision? Does the atmosphere contain compounds difficult to maintain without industry? Each clue would remain uncertain alone, but science rarely depends on one clue. It builds confidence through convergence. Earth may already offer convergence. Imagine the first report written in another language under another star. It would not begin with humans. It would begin with a star catalog entry, a spectral class, a distance, a luminosity, a set of periodic measurements. The observers would note that the third small planet lies within the circumstellar region where surface liquid water is plausible. They would describe its radius as close to 1 planetary unit by their own measure, its orbit as stable, its atmosphere as active. They would add that the world's spectral profile suggests oxygen-rich air and surface water. At first, this would be a scientific curiosity, valuable but not alarming. Later reports would become more animated. The atmosphere refuses simple explanation. The planet shows long-term chemical disequilibrium. Seasonal variation appears consistent with a biosphere. Cloud patterns indicate an active climate system. Surface reflectance changes with rotation and orbital position. The world is not merely habitable in theory. It is occupied by processes that resemble life. Their instruments may not resolve a single organism, but the atmosphere itself behaves as though the surface is alive. Then the file changes tone. Carbon dioxide rises rapidly by geological standards. Methane follows. Artificial molecules appear, depending on instrument sensitivity and distance. Night-side brightness increases in patterns that do not resemble volcanism, lightning, or aurora. Orbital objects become detectable in close proximity to the planet. The observers may debate whether this indicates intelligence, industry, or a brief unstable phase. They may compare Earth with other biological worlds in their archives, if such archives exist. Perhaps they have seen planets bloom and fall silent. Perhaps they have seen technology appear as a fever in the atmosphere. The report would be clinical. It would not need fear or wonder to be profound. A living planet has produced a technological species. The species has begun modifying atmospheric chemistry, placing machines in orbit and emitting structured radiation into space. The civilization is young, energetically noisy, and potentially vulnerable. Further observation recommended. No contact advised until cultural, biological, and strategic risks are better understood. The last sentence may be the one we would never read. Continue watching. Such a report would also contain ignorance. It might know our planet better than it knows us. It might infer industrialization without knowing poetry, detect satellites without knowing ambition, measure atmospheric change without knowing fear. This is the tragedy of distance. It permits knowledge while denying intimacy. Earth could be one of the most carefully observed worlds in a distant archive, and yet the observers might understand almost nothing about what it feels like to stand under rain, bury the dead, invent a number, hear music, or look into the sky and wonder whether anyone is looking back. Perhaps their report would include uncertainty as a formal category, biosphere confirmed with high confidence, technology suspected with moderate confidence, stable long-term survival unknown, contact risk unresolved, monitoring priority increased. That language may sound cold, but our own sciences speak the same way when the stakes are immense. Clinical language is how intelligence protects itself from emotion while standing near the edge of revelation. The silence of the sky is often treated as evidence of absence, but silence can also be a behavior. A civilization capable of observing Earth may decide that speaking is unnecessary, dangerous, premature, or ethically forbidden. Contact is not the natural endpoint of discovery. When humans observe animals in the wild, we often try not to interfere. When scientists study an isolated ecosystem, contamination becomes a moral and practical concern. A distant intelligence may apply the same logic to planets that have only recently become technological. There are many reasons to remain quiet. A civilization may not know whether Earth is safe. It may fear revealing its own position. It may follow a rule against disturbing younger worlds. It may lack any desire to communicate with a species still unable to manage its own planet. It may consider our signals too primitive to answer. It may watch on timescales that make human impatience irrelevant. To beings who have survived for hundreds of thousands or millions of years, a century of radio leakage may resemble the first brief crackle of a campfire in a valley. Silence may also arise from distance. Even if alien observers detect Earth, a message takes time. A civilization 100 light-years away sees Earth as it was 100 years ago. If it sends a reply, another 100 years pass before the signal arrives. Contact across interstellar distance is never a conversation in the ordinary sense. It is correspondence between epochs. By the time an answer reaches us, the civilization that sent it may have changed, and so may we. Silence may be nothing more mysterious than the scale of the problem. There is another possibility, more uncomfortable because it removes drama. They may be watching because observation is enough. Curiosity does not require friendship. Knowledge does not require rescue. A distant civilization might collect biospheres the way we collect spectra, mapping the rare chemistry of living worlds without any need to enter their histories. Earth could be fascinating, fragile, and still not important enough to interrupt. The universe may contain watchers whose highest virtue is restraint. Silence may also be cultural. A civilization old enough to survive its most dangerous technologies may have learned habits that younger species find unnatural. It may value patience over expression, continuity over expansion, invisibility over glory. Human beings often assume that intelligence announces itself because our own intelligence has been noisy, expansive, and restless. Another lineage may have reached the opposite conclusion through history we cannot imagine. Its wisdom may consist in leaving very little trace. A silent civilization would frustrate our search because it would behave unlike us at the precise point where we expect recognition. We listen for signals because we would send signals. We imagine contact because we desire contact. But advanced intelligence may not become more communicative with age. It may become more selective. It may speak only through narrow channels, only to known partners, only after long observation, or only when silence becomes more dangerous than speech. The idea that Earth might be deliberately left alone is often called the zoo hypothesis. It imagines advanced civilizations treating developing worlds as protected environments. Under this view, the absence of open contact is not accidental. It is policy. Earth is observed, perhaps studied, perhaps even catalogued, while direct interference is avoided. The comparison is imperfect, but powerful. A zoo is not just a place where animals live. It is a place where one side understands the enclosure and the other side does not. The hypothesis appeals because it explains too much too easily. If aliens are silent, perhaps they are hiding. If we see no probes, perhaps they are concealed. If we receive no message, perhaps contact is forbidden. Any lack of evidence can be absorbed into the theory, which makes it difficult to test. Yet the emotional force remains. Humans know what it means to observe without being seen. We do it with cameras in forests, satellites over weather systems, microscopes over cells, and telescopes over worlds. We already live in a civilization built around asymmetrical observation. A more modest version is easier to defend. Alien observers may not be enforcing a grand galactic quarantine. They may simply be cautious. Contact with a young technological species could be unpredictable. Even a harmless message might alter religions, politics, science, economics, and collective self-understanding. A single verified signal from another civilization would become one of the deepest events in human history. An advanced society might understand that burden and choose delay. Watching may be the least invasive form of knowledge. The darker shadow of the zoo hypothesis is the possibility that observation is not benevolent. A world can be watched for protection, study, exploitation, or strategic assessment. The same telescope can serve curiosity or suspicion. The same silence can mean patience or indifference. Without contact, we cannot know the intention behind the gaze. That uncertainty is what makes the question endure. Being watched would not automatically mean being cared for. It would mean we are visible to minds whose motives may not resemble our own. There is also a colonial danger hidden inside the metaphor. Humans have often described other peoples, animals, and ecosystems as objects of study before deciding what to do with them. Observation can be the first gesture of respect, but it can also be the first gesture of control. An alien society may have ethical principles far more sophisticated than ours, or principles narrower and colder. The distance between watcher and watched does not tell us which is true. The zoo hypothesis therefore reveals more than one fear. It asks whether we are alone, but it also asks whether knowledge without consent is a form of power. If Earth is being observed without contact, humanity has not agreed to participate in the experiment. Yet every world visible through a telescope is observed without consent. The universe does not grant privacy to planets. Any atmosphere exposed to starlight can be read by whoever learns the language. Another idea gives silence a harsher explanation. In the dark forest view, the galaxy is dangerous because every civilization is uncertain about every other. No one can know the intentions, capabilities, or future trajectory of a distant intelligence. A young species may become powerful. A peaceful species may change. A message meant as greeting may become a map for attack. Under this logic, survival favors concealment. Civilizations listen, hide, and avoid making themselves easy targets. If aliens are already watching us, the dark forest interpretation becomes troubling. Earth has not been quiet. Our planet has leaked radio signals, fired radar into space, altered its atmosphere, illuminated its nights, and launched machines beyond its atmosphere. We have made ourselves more visible without knowing who might be able to notice. Yet the danger should not be exaggerated into fantasy. Most ordinary broadcasts weaken quickly with distance. Space is vast, and detection is difficult. Our strongest signals are not equivalent to a lighthouse sweeping the whole galaxy. Still, the principle remains. Technology leaves traces. A civilization that values concealment may study Earth from afar while refusing to transmit. It may treat every new technological world as a potential future actor in the galaxy. The first question would not be whether humans are wise or beautiful. It would be whether we are detectable, expandable, unstable, or likely to send probes one day. Our wars, atmospheric damage, scientific acceleration, and orbital growth would form part of a strategic profile. To such observers, Earth might look less like a neighbor and more like a variable. The dark forest is not a proven description of the cosmos. It is a thought experiment about uncertainty. Its power lies in the gap between knowledge and trust. Even if a civilization detects life on Earth, it may know almost nothing about the inner life of our species. It may see chemistry, industry, and energy use, while missing music, grief, mathematics, tenderness, cruelty, memory, and law. Distance turns cultures into signals. Signals are easier to fear than people. The strongest version of this idea depends on a terrifying simplicity. If the future power of another civilization cannot be predicted, then even a harmless world may become a threat. A small species that builds rockets today may build starships tomorrow. A planet that barely controls its orbit may one day move asteroids, seed colonies, or reshape entire systems. The distance between weakness and power may be short on cosmic timescales. To an ancient watcher, humanity's present fragility may matter less than its trajectory. Yet caution should not become certainty. The galaxy may contain cooperation, indifference, isolation, failed searches, rare intelligence, or civilizations separated by timescales too large for contact. The dark forest is one possible reading of silence, not the only one. Its value is that it disciplines our optimism. It reminds us that being visible is not automatically safe, and that intelligence does not erase fear. Any species that has survived long enough to watch others may have its own history of danger. Humanity did not become visible all at once. It brightened by degrees. The first large-scale technosignature may have been atmospheric. Fires, agriculture, then industrial combustion changing the composition of the air. Later came radio. In the 20th century, Earth began producing artificial electromagnetic noise in new forms. Broadcasts, military radar, television carriers, planetary radar experiments, deep space communications, and spacecraft telemetry all added to the expanding shell of human activity moving outward at the speed of light. That shell is often imagined as a clear bubble of human culture, filled with old music, speeches, wars, advertisements, and news. The reality is more difficult. Many signals become too weak to distinguish from noise after relatively short cosmic distances. Others are narrow, directed, brief, or intermittent. A civilization would need sensitive equipment, favorable geometry, and knowledge of what to search for. They might not receive our television as intelligible content. They might detect an artificial pattern, a carrier wave, a pulse, or nothing at all. But Earth has also produced stronger signals. Planetary radar aimed at nearby objects can be intense, though narrowly directed. Deep space communication systems send focused beams toward spacecraft. If a distant observer happened to lie within the path of such a beam, the signal could be more noticeable than ordinary leakage. The problem is alignment. Much of our loudest communication is not sprayed evenly across the sky. It is directed toward machines we built, traveling through specific corridors of space. A patient watcher would combine clues. No single signal needs to reveal everything. A rising industrial atmosphere, artificial electromagnetic emissions, orbital satellites, thermal anomalies, and the timing of planetary changes would form a pattern. Technosignature science is partly the science of patterns too coordinated to be natural. Earth is becoming one of those patterns. The question is not whether we have announced ourselves perfectly. The question is whether we have become interesting enough to investigate. The irony is that we often imagine our broadcasts as messages, while our largest message may be unintentional. We did not increase carbon dioxide to speak to the stars. We did not light our cities to form a galactic signal. We did not launch satellites as proof of intelligence for foreign astronomers, yet unintentional signatures may be more honest than ceremonial ones. A deliberate message can be edited. A planet's atmosphere records behavior. If an alien civilization studies technosignatures, Earth would offer a useful case because it is early. We have not yet built planet-sized engineering, blocked starlight with vast structures, or colonized the solar system. Our signatures are modest, confused, and transitional. That may make them scientifically precious. A mature technological world shows what intelligence becomes after endurance. Earth shows what intelligence looks like near ignition, when the first tools capable of changing a planet are still in the hands of a species shaped by local instincts. From a nearby world, Earth would not look like the Earth we know. It would be a pale dot near a bright star, difficult to separate from glare, visible only through careful technique. Oceans would not glitter as a human sees them. Forests would not appear as trees, cities would not appear as streets. The whole planet would be compressed into a fraction of a pixel, and yet that fraction could contain almost everything important. Rotation would change its brightness. Clouds would soften its rhythm. Continents and oceans would shape its color. Seasons would alter its spectrum. If the observers were close enough and technologically advanced enough, they might build images over time. They could reconstruct crude maps from changing light curves, much as scientists infer the surfaces of distant objects from variations in brightness. They might identify that Earth has oceans, a mixed surface, polar ice, and a dynamic atmosphere. They might notice the moon, large enough to affect observations, and perhaps revealing something about tides and planetary stability. They might understand that Earth is not alone, that it belongs to a system with a striking architecture. The moon itself would be a clue. A large natural satellite changes tides, stabilizes axial tilt, and records violence in its cratered surface. From afar, the Earth-Moon pair might look like a distinctive double world, one alive and blue, the other dry and silent. Alien scientists could wonder whether the moon helped make Earth stable enough for complex life, or whether it is merely a companion born from ancient impact. They would not need mythology to find the pair beautiful. Their equations would carry enough wonder. What would they think of us? That depends on what their instruments can resolve. If they see only atmospheric change, they may know a technological species exists without knowing its shape. If they detect satellites, they may infer orbital engineering. If they capture artificial light, they may recognize surface energy use. If they intercept transmissions, they may know we communicate. But the deeper truth of humanity would remain hidden. From interstellar distance, our entire civilization may be reduced to chemistry, heat, and light. The reduction would be cruel but familiar. We do the same to distant planets because distance forces abstraction. A world becomes a radius. An atmosphere becomes a spectrum. A possible ocean becomes a line in a paper. Yet behind each measurement there may be storms, mountains, beaches, silence, and forms of life we cannot picture. If alien observers study Earth, they would face the same limitation in reverse. They might know enough to suspect intelligence, but not enough to know whether that intelligence dreams, suffers, worships, jokes, remembers, or mourns. If they were close enough to detect city lights, Earth's night side might appear like a nervous system flickering across continents. Coastlines would glow, rivers of light would mark human settlement. Dark regions would speak as loudly as bright ones, revealing deserts, oceans, forests, mountains, poverty, policy, geography, and history without explaining any of them. The pattern would be artificial but not self-explanatory. It would show a species unevenly distributed across its world, powerful in clusters, absent across vast regions, gathered near water and trade, building light against the dark. Every act of watching across space is also an act of watching the past. Light does not carry the present, it carries what was. A civilization 10 light-years away sees Earth as it was 10 years ago. 100 light-years away, it sees the early 20th century. 1,000 light-years away, it sees the Middle Ages. 10,000 light-years away, it sees a world before agriculture had reshaped much of the planet. The farther the watcher, the younger Earth becomes in their sky. This creates a strange asymmetry. If aliens are observing us from a great distance, they may not know that we exist as a technological civilization yet. They may see a biological Earth with no obvious industry. They may see early human changes in land use or nothing beyond the ancient signal of life. Our technological phase has been brief. The radio-bright portion of human history is a thin skin of time, barely more than a century old. On galactic scales, it has hardly begun. Nearby observers are different. Within 100 light-years, the evidence of modern humanity may be arriving now. Within a few dozen light-years, they could know that Earth entered an industrial and electromagnetic phase. Within the closest stellar neighborhood, a sufficiently advanced civilization might already have seen the atmosphere change, detected artificial emissions, or noticed unusual activity near our planet. But the number of possible observers shrinks as distance narrows. The closest stars are few. The nearest planets may be common, but intelligent life remains unknown. Time also affects response. If a world 50 light-years away detected our early radio leakage and sent a message immediately, the reply would take 50 years to reach us. A full exchange would span a century. A misunderstanding could last generations. A question asked by one civilization might be answered by its descendants, or by no one. Interstellar communication turns history into dialogue. This may be one reason watchers remain watchers. Observation is continuous, conversation is slow, fragile, and irreversible. This delay transforms every motive. A warning may arrive after the danger has passed or after the disaster has happened. A greeting may reach a civilization that no longer resembles the one first observed. A threat may be based on a century-old misunderstanding. Even generosity becomes complicated when time stretches the act of help into history. The watchers may see us now, but any response belongs to another version of Earth. There is also the possibility that many civilizations miss each other by time rather than distance. One world may become technological after another has already fallen silent. One species may listen during an age when its neighbors have retreated into narrow signals. Another may speak loudly for a few centuries, then mature into quietness before anyone nearby develops the instruments to hear. The galaxy may contain signals that pass like ships in fog, each real, each alone in its own era. When humans imagine alien observers, we tend to imagine beings with eyes, counsels, motives, and decisions. But the watchers may not be biological in any familiar sense. A civilization advanced enough to study Earth could have delegated observation to machines. Autonomous telescopes, probes, arrays, or artificial intelligences could survey planetary systems for millions of years, collecting data long after their builders changed or vanished. The galaxy may be easier to monitor with patient machines than with living crews. A machine watcher would not need drama. It could orbit a distant star, drift between systems, or sit in the cold outskirts of a planetary system where sunlight is weak and detection is difficult. It could wake when a planet changes, transmit compressed reports, repair itself, or wait through centuries of silence. Such devices would be extensions of curiosity and caution. They might be closer than a home civilization, perhaps even placed in strategic locations to observe promising worlds. The solar system offers many hiding places, though no evidence proves anything is there. The asteroid belt, the outer planets, Trojan regions, Kuiper belt objects, and distant orbits provide vast volumes where small objects would be difficult to notice. Human surveys are improving, but we do not have perfect knowledge of every artificial object that could exist in the outer solar system, especially if it were dark, quiet, and small. This does not mean such a probe exists. It means absence of evidence is weak in regions we have barely examined. Still, the most efficient alien observation platform may be far simpler, a telescope around their own star. Interstellar probes are expensive, risky, and slow. Light brings Earth to them every moment. A civilization with vast optical arrays, interferometers, star shades, or instruments beyond our current engineering could study Earth without sending anything here. The Watchers may not be hiding in our system at all. They may be looking from home, with mirrors larger than our cities and patience older than our civilizations. Such instruments are not magical in concept. Even our own science imagines interferometers that combine light from separated telescopes to achieve extraordinary resolution. We imagine star shades that block stellar glare so that faint planets can be seen beside bright suns. We build coronagraphs, adaptive optics, space observatories, and detectors tuned to wavelengths invisible to the eye. Give that path thousands of years, larger resources, better materials, and a culture willing to build across space, and the distant Earth becomes less inaccessible. A machine civilization would make this still more plausible. Biological observers have limited lifetimes and fragile bodies. Machines can be copied, repaired, distributed, and slowed to the pace of astronomy. They can store centuries of data without boredom. They can compare spectra across millennia. If the Watchers are machines, the question of patience changes completely. Waiting is not a sacrifice to a device designed for waiting. If Earth is being watched, the question becomes moral as much as scientific. What does a mature civilization owe to a younger one? Should it reveal itself when it discovers intelligence? Should it wait until the younger species becomes stable? Should it remain silent forever, allowing natural development to continue? These questions are not alien to us. Humanity already faces versions of them when studying uncontacted tribes, endangered species, archaeological sites, and fragile ecosystems. Knowledge gives power, and power creates responsibility. The difficulty is that responsibility depends on values. An alien civilization may not share our categories of dignity, freedom, harm, or consent. It may believe that non-interference is sacred. It may believe that guidance prevents catastrophe. It may believe that young civilizations are too dangerous to ignore. It may believe that all life belongs to a common archive. Or it may have no unified belief at all, because civilizations are not single minds. They contain factions, histories, disagreements, and accidents. Contact would not simply answer the question of whether we are alone. It would change the conditions under which we ask every other question. Religion would reinterpret its place. Science would inherit new horizons. Politics would confront a scale it was not built to manage. Economics would absorb uncertainty. Some people would feel liberated, others diminished, others afraid. A responsible watcher might understand that revelation is not a neutral act. To be seen by a greater power can destabilize the story a species tells about itself. Yet silence has its own ethics. If an older civilization knows that Earth is approaching ecological danger, nuclear risk, artificial intelligence instability, or other self-made threats, does restraint remain moral? Would warning us be help or interference? Would we even believe the warning? A signal from the stars might unite humanity for a moment, or become another object of conflict. The Watchers, if they exist, may have concluded that wisdom cannot be transmitted before a species is ready to use it. The question becomes sharper if they have seen other worlds fail. A civilization with a long archive may know patterns we do not. It may have watched young technological species poison their atmospheres, destroy themselves in war, lose control of machines, or retreat into silence. It may also have watched others survive, stabilize, and become careful. Earth's present age might be legible to them as one phase in a known sequence. They may know which signs predict endurance and which signs predict collapse. That knowledge would create a terrible temptation. To intervene could save a world or deform it forever. To remain silent could preserve its freedom or allow preventable ruin. No ethical system escapes the problem cleanly. The more powerful the observer, the heavier the burden of restraint. If alien watchers exist, their silence may not be empty. It may be full of argument. The absence of visible alien observation is not surprising. Watching from afar leaves little trace. A telescope around another star does not glow for our benefit. A civilization could observe Earth for centuries without producing any signal aimed at us. Even if it transmitted data internally, the beams might never cross our instruments. Space is not a room where every action echoes equally. It is a geometry of narrow lines, weak signals, and overwhelming distances. Our searches are also young. SETI has listened to portions of the sky at selected frequencies for limited periods. The search is profound, but it is not exhaustive. We have not monitored every star continuously across all wavelengths. We have not examined every possible type of technosignature. We have barely begun to search for industrial gases in exoplanet atmospheres, waste heat from large-scale engineering, unusual night-side illumination, or faint artificial patterns in distant systems. The silence we observe is partly the silence of our own incomplete instruments. There is also the problem of expectation. We search for what we can imagine. Radio signals made sense because we use radio. Laser pulses make sense because we build lasers. Megastructures make sense because we understand energy collection. But an older civilization may communicate in ways that leave no obvious trace to us, or may have abandoned broad communication entirely. It may use tight beams, quantum-resistant archives, neutrino channels, gravitational techniques, or methods beyond present engineering. Some possibilities sound speculative because they are. The larger point is simple. Our net is narrow. Even if aliens were watching Earth specifically, they might avoid detectable emissions. A civilization aware of the risks of exposure would design its observatories to be quiet. It would not advertise itself to every young world it studies. It would not need to hover near Earth in shining craft. It would not need to interrupt aircraft or appear in military footage. The most plausible watcher may be almost perfectly boring, distant, silent, methodical, and invisible because it has no reason to be seen. This is why the absence of spectacle matters so little. Popular culture teaches us to expect alien presence as interruption, lights in the sky, impossible maneuvers, voices in receivers, metallic ruins, bodies, messages, evidence that overwhelms denial. Scientific observation could be the opposite. It could leave no footprint at all on the observed world. We might be studied with exquisite care and experience nothing unusual from our side of the glass. Our own searches must therefore broaden without losing discipline. The real question is not whether a strange light has appeared in the sky, but whether the universe contains patterns that natural astrophysics cannot easily explain. The search for watchers is part of the larger search for technosignatures, structured emissions, artificial atmospheric chemistry, waste heat, engineered orbits, unnatural timing, and other traces of purpose. It is a slow search because nature itself is inventive. The burden of proof must remain high. The question of alien watchers carries a psychological danger. It flatters us. To imagine that someone is watching Earth is to imagine that Earth matters. It places humanity inside a cosmic attention we have not earned and cannot verify. This is why the idea must be handled carefully. The universe is large enough to make us visible, but also large enough to make us ordinary. A distant civilization may find Earth interesting, or it may have cataloged thousands of living worlds. We may be remarkable, routine, or unnoticed. Human beings are skilled at turning uncertainty into narrative. Ancient cultures filled the sky with gods, animals, heroes, and omens. Modern culture fills it with civilizations, probes, empires, and hidden observers. The machinery changes, but the impulse remains. We look upward and feel that the dark should answer. When it does not, we invent possible reasons. Some are scientific, some philosophical, some fearful. The question of alien observation lives at the boundary between evidence and longing. But the scientific version of the question does not require self-importance. Earth is genuinely detectable in principle. Its atmosphere genuinely contains signs of life. Its technological activity genuinely alters the planet. The Earth Transit Zone genuinely gives some stars a better view of our world. Exoplanets are genuinely common. These facts do not prove we are being watched, but they make the idea physically coherent. The proper response is neither belief nor dismissal. It is disciplined curiosity. Perhaps the hardest thing is to accept that being watched would not necessarily make us central. An astronomer can study a planet without loving it. A machine can record a biosphere without pity. A civilization can classify another world without destiny. If aliens are watching, they may not be waiting for us to become heroes of the galaxy. They may be waiting to see whether we survive the ordinary dangers of intelligence. The longing to be seen is deeply human. Children look for witnesses. Nations build monuments. Scientists publish discoveries. Artists leave traces for strangers unborn. Even our spacecraft carry plaques, records, names, and symbols as though we cannot cross a threshold without trying to tell the dark who we are. The thought of alien watchers touches that longing and unsettles it. Being seen by another intelligence would fulfill one ancient desire, but it might also reveal that visibility does not guarantee understanding. The mature response is to separate wonder from vanity. Earth is worth studying because it is a living planet, not because humans require cosmic attention. Humanity is worth preserving because conscious life is difficult and fragile, not because the universe owes us an audience. If watchers exist, their gaze should not become a substitute for meaning. Our task remains local, immediate, and material, to live well on the world that made us visible. There may be a threshold beyond which Earth becomes difficult to ignore. For billions of years, the planet signaled life. For centuries, it signaled industry. For decades, it signaled orbital capability. The next stages could be louder. Large constellations of satellites, powerful lasers, planetary-scale climate engineering, fusion infrastructure, permanent lunar bases, asteroid mining, or interplanetary travel would make human activity more visible. A civilization that once classified Earth as biological might reclassify it as technological. The moment of notice may not be dramatic. It could happen as a line in an automated survey. Anomalous atmospheric compound detected. Artificial night-side luminosity increasing. Orbital object population rising. Narrowband emission candidate. Reobserve. The machinery of discovery may be bureaucratic even among the stars. Great revelations often arrive as data quality improves, not as thunder. Somewhere, if observers exist, Earth may already have crossed from curiosity into watch list. What would they see in our present age? They would see brilliance and disorder together. A species capable of mapping its genome, splitting atoms, landing machines on other worlds, detecting gravitational waves, and building telescopes that see the early universe. The same species warms its own atmosphere, poisons ecosystems, threatens itself with weapons, and struggles to coordinate across borders. From afar, human civilization might look like a flare, sudden, energetic, unstable, beautiful in output, dangerous in trajectory. This may be why no message comes. A watcher may want to know which direction the curve bends. Do we stabilize or collapse? Do we expand carefully or violently? Do we learn to manage planetary power, or do we burn through the conditions that made us possible? The answer may matter more than any greeting. Before an older civilization speaks, it may first ask whether humanity is becoming a participant in cosmic history or another brief experiment in chemistry and fire. There may be thresholds of maturity that cannot be measured by technology alone. A species may split atoms before it learns restraint. It may reach its moon before it learns how to share a planet. It may build telescopes capable of studying the beginning of time while struggling to protect the future of its own children. To a distant observer, this contradiction would be central. Intelligence is not the same as wisdom, and technical power can arrive before moral coordination. The next century may therefore be more visible than the last. If humanity builds stable lunar infrastructure, sends crews to Mars, deploys larger orbital systems, or begins moving significant industrial activity beyond Earth, the solar system itself will start to look altered. A watcher would see a species crossing from planetary technology into early interplanetary presence. That transition may be one of the rarest and most dangerous stages in the life of intelligence. The possibility of being watched should not lead to panic. It should lead to humility. Our planet is not sealed. Its atmosphere is observable. Its technology is becoming more visible. Its future may be judged, if not by alien minds, then by the physical consequences of our own actions. We already live under observation from our own instruments. Satellites watch forests fall, ice retreat, cities spread, storms intensify, and oceans warm. The alien gaze is hypothetical. The planetary record is real. If we want to be the kind of civilization worth finding, the first task is not to craft a perfect message for the stars. It is to become coherent on our own world. Any distant observer would not need to hear our speeches about intelligence. It could watch our atmosphere. It could watch our energy use. It could watch whether knowledge makes us more careful. A species announces itself through consequences. Earth's most honest broadcast is not radio. It is the condition of Earth. SETI, exoplanet astronomy, planetary defense, climate science, and space exploration all belong to the same broader awakening. We are learning that planets can be detected, characterized, altered, protected, and lost. We are learning that life leaves traces and technology leaves stronger ones. We are learning that the universe may contain many worlds while still offering no guarantee of rescue. The idea of watchers returns responsibility to us. If someone is looking, they are seeing the truth, not the story we prefer. And if no one is watching, the conclusion remains nearly the same. The silence does not make Earth less precious. A living world in a vast dark is rare enough to deserve care even without witnesses. The stars do not need to contain judges for our choices to matter. But the possibility that another intelligence could already see us adds a strange pressure to the age we inhabit. We are becoming visible at the same moment we are deciding what kind of visible civilization we will be. This is the practical meaning of the question. It does not require belief in hidden visitors. It asks us to imagine Earth from outside, stripped of our excuses. Seen from afar, our divisions vanish. Borders disappear, languages disappear, ideologies disappear, the atmosphere remains, the oceans remain. The night side glows, the heat balance changes, the machines multiply. From that distance, our civilization is judged by the mark it leaves on the only living world we know. To think this way is useful even without aliens. It is a discipline of perspective. It forces humanity to see itself as a planetary force rather than a collection of separate dramas. We have become part of Earth's geology, chemistry, and future light. Whether the watcher is an alien telescope, a human satellite, or the indifferent record of nature, the evidence will be the same. The planet will remember what we did. Perhaps the deepest unease in the question is that alien watchers would turn humanity into an object of study. We are accustomed to being the observer. We name stars, classify galaxies, measure planets, dissect atmospheres, and assign probabilities to life we have never touched. We look outward with instruments and call it knowledge. But the same universe allows the gaze to reverse. Somewhere, under another sky, Earth may be the distant planet, the spectral anomaly, the fragile biosphere, the developing intelligence that appears in the data before it ever appears in person. This reversal should not humiliate us. It should clarify us. For centuries, humanity placed itself at the center, then learned that Earth orbits the sun orbits the galaxy belongs to a cosmic web, and the observable universe contains more worlds than our ancestors could have imagined. Each displacement seemed to reduce us, yet each one gave us a larger reality to inhabit. Being watched, if it is happening, would be another displacement. It would mean our story is not private. It would mean intelligence is not a human possession. It would mean the sky has context we have not entered yet. Still, there is a dignity in the uncertainty. We do not know whether alien astronomers have marked Earth in their catalogs. We do not know whether any civilization has seen the oxygen in our air, the water in our spectrum, the industrial scar of our century, or the thin glitter of machines around our world. We do not know whether silence means absence, caution, distance, indifference, or patience. The unknown remains intact, and perhaps that is why the question endures. It does not ask us to believe in visitors. It asks us to understand that visibility has consequences. If aliens are already watching us, they are watching a young species at the edge of self-knowledge. They are watching a planet alive enough to change its own air, intelligent enough to notice the stars, and restless enough to wonder whether the stars have noticed back. They are watching our first uncertain steps beyond the atmosphere, our first attempts to listen, our first catalogs of other worlds, our first recognition that Earth itself is a signal. And whether the watchers exist or not, the mirror has already turned. We now know that planets can reveal themselves across the dark. We now know that life can write itself into light. We now know that anyone searching carefully from the right place may one day find us. That knowledge may be the true contact for now. Before another civilization speaks, before any signal crosses the void, before any proof arrives, we have already entered a larger moral landscape. We know that Earth is observable. We know that other worlds may be observable too. We know that life, if it exists elsewhere, may be waiting inside faint spectra and difficult shadows. The universe has become less silent because we have learned how to ask better questions. Perhaps somewhere, another intelligence has asked the same question in reverse. Perhaps it has looked toward the sun and wondered whether the small blue world passing before it contains minds. Perhaps it has debated whether to speak, whether to wait, whether to fear, whether to care. Or perhaps there is only the light, crossing the distance without witness, carrying the history of our oceans and cities into an emptiness that has no opinion. In either case, Earth continues to shine. Its signal expands. Its future remains unfinished.